Find an equation of the line passing through the given points. Use function notation to write the equation. All right, so we have several things that's going on in this particular example. Number one, our goal is to find this equation, and then at the end we're going to write it as a function notation. And we talked about this um, uh, in the first set of modules that we covered, how to change a linear equation into a linear function, and that's just by replacing y with f of x. So we are going to use several formulas here. Of course, we're going to use the point slope formula. We're going to use this formula because, well, we have a set of points and we also have the slope. But what's missing in this particular question is the slope. It's giving us two sets of points. Okay, that's fine and good, but in order for us to use the point slope formula, we need to know the slope. So since we need to know the slope, we need to find it. And in finding the slope, we're going to use the formula m is equal to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. And no matter what, your ordered pairs are always the same. The first set of points, we'll label them as with the subscript of 1. The second set of points, we'll label that with the subscript of 2. Now we're going to plug everything that we have into this equation, into the formula to find the slope. So here we have 15 minus 9 all over negative 7 minus negative 4. So 15 minus 9 gives us 6. And then we know that negative 7 minus 4, that's going to become a plus. And that's negative 7 plus 4 will give us negative 3. And 6 divided by negative 3 is negative 2. So we have a slope of negative 2. So now we have all of the information that we need to write this equation. So let's use the point slope formula, and the set of points that we're going to use, it doesn't matter. You can use the first set or the second set. You will still yield the same answer. So just to keep in line with the formula, we'll use the first set of points, the negative 4, 9, and our slope. So using the point slope formula, we have the slope, which is negative 2. We have a set of ordered pairs, which is negative 4, 9. Let's plug it into the formula. Y minus 9 is equal to negative 2 times. You're saying x minus negative 4, and that becomes x plus 4. And let's solve for y, because we're going to put it in slope-intercept form as well. So we have here y minus 9 is equal to negative 2x minus 8. Then we're going to add 9 to each side, and we have y is equal to negative 2x plus 1. So this is our equation. You can always check your work by plugging these points in for the coordinates of x and y to see if they're equal to each other. Lastly, it's calling for us to write the equation as a function. So this is the linear equation. Now we want to write it as a linear function. Which is function notation. All we're doing is replacing y with f of x. So we have here f of x is equal to, and then write everything as is, negative 2x plus 1. And this is our answer. Let's look at the next example. The next example in your notes is a line that is graphed. And that line is graphed has 2 points that's identified on that line. And the first point is 2, 5. And the second point is -4, 1. So we're going to do the same thing like we did for the last example, where we're going to need several formulas. Number one, because it's asking us to find an equation of the line, we are going to use the point slope formula. We have the ordered pairs. We have -4, 1 and 2, 5. But before we can use the point slope formula, we need to first find the slope. So let's label and let's substitute into the formula. We have 5 minus 1 all over 2 minus -4. 5 minus 1 is 5 minus 1 is 4. 2 minus -4, that is 2 plus 4, which is 6. And then we reduce that to give us 2/3. Okay, so we have our slope. Slope, which is 2/3. We have a set of ordered pairs. It doesn't matter which set we use. Let's use 2, 5 this time. We're going to plug into the point slope formula. So here we have y minus 5 is equal to 2/3 times x minus 2. And let's solve. We're going to distribute the 2/3. And we have 2/3 times x, which is 2/3 x, minus 2/3 times minus 2, that would give us -4/3. Okay, so let's do some algebra here, because the question, how it wants us to write the answer, it says write the answer in standard form. So standard form is ax plus by is equal to c. So we're going to have to do some converting. So we want all of our x and y to be on one side. So what we're going to do is we can add 5 to both sides, but I want us to hold off for a second. Let's solve this equation without having any numbers in the denominator. So since we don't want to have a denominator, we're going to multiply all terms on both sides by 3 to get rid of the denominators. So then we have 3y minus 15 is equal to, on the right hand side, the 3's are going to divide out. We have 2x minus the 3's are going to divide out here, 4. So your goal, you want x and y to be by itself. You want the number, which is 15. We have 15 and minus 15 and minus 4. We want to get those together, bring those together. So let's move the 15 over first. We're going to add 15 to both sides. We have 3y is equal to 2x plus 11. And then we want to bring the x over by subtracting 2x to both sides. And we have -2x plus 3y is equal to 11. All right, so it's in standard form, but remember, we never want to have a negative term when we're writing our solution in standard form. So what we're going to do is multiply both sides by -1. So it's okay if the y is negative and the constant term, but we don't want the x term to be negative. So we multiply both sides by -1, and then our answer is going to be positive 2x minus 3y is equal to -11. When we're multiplying both sides by -1, you have to multiply the -1 to every term. And that is our solution.